Hello and welcome to this section 3.4 lecture. Today we're going to talk about how we multiply rational numbers. Okay, so we've multiplied integers already, and we're going to just extend that to give us some rational numbers. Okay, so the first thing they want to talk about is multiplying rational numbers with different signs. So the sign rules for the product, basically when we have different signs, as in one is positive and one is negative in either order, and this is the great thing about multiplication, is that if we're multiplying here, so I might want to even note like this times this, it equals a negative. All right? If they have different signs, it's going to equal a negative. And this kind of comes from the fact that multiplication is just repeated addition. So the easier way to look at it is the positive and then the negative. So if you add together a negative number, however many positive times you have, you're going to end up with a negative. This way is kind of weird, talking about the kind of like the opposite of adding. It's not really, but if you're adding a negative number of positive numbers together, or doing that multiple times, like that's kind of a weird way to look at it. But either way, positive times a negative gives us a negative. Okay. In this first completed example, they talk about Gina hiked down a canyon, stopped each time she descended a half a mile to rest, and she hiked 4 total sections. What is her overall change in elevation? So she's obviously hiking, probably not straight down, but just looking at her elevation, she's starting at some height and she's moving down. Her elevation changes a half a mile, and she takes a rest, and she does that 4 times. Hikes down half a mile and hikes down half a mile. So the question is, how far in total did she end up hiking when she did that? So we start at 0. That's what they're doing, is just kind of doing it relative to 0, just to figure out how far she's actually making it. So down 1/2 mile takes it to negative half a mile, negative 1 mile, negative 1.5, and negative 2 miles. Okay. So then we kind of get into rules for multiplying fractions. Now, if fractions are good for anything, which we've already talked about, adding and subtracting, not really their cup of tea, not really the best thing that they do. But what they do really well is fractions multiply really well. Okay? So if I'm looking at this 4 times negative 1/2, what I'm actually looking at, which I wish they went a little bit further into detail about, is we look at it as 4 over 1 times negative 1 over 2. Again, I always like to have the negative as a part of the numerator, as opposed to looking at it as part of the fraction in general. I like to think of it as part of the numerator. And then the trick to multiplying fractions is you multiply straight across. Okay, so 4 times negative 1 is negative 4, and 1 times 2 is 2, and then you can simplify that. In this problem, they want us to multiply 2 by negative 3.5. So we're going to move back from 0, 3.5, 2 times. Okay. So if I move 1 time 3.5, or negative 3.5, and then I move another time negative 3.5, oh, I didn't make it 3.5, did I? I only made it 2.5. Let's try that again. So start at 0, get to negative 3.5, and then I want to go another negative 3.5. It's apparently a long ways. I end up at negative 7. Okay. Now if I'm multiplying two numbers together that have the same sign, and again, this is the factors are the pieces of a multiplication problem, so we can think of this as positive times positive equals a positive, and negative times negative equals a positive. Basically, if you have the same sign, you get a positive as your answer. Okay. And so they kind of do some weird things here to get us to realize that, because it's not the easiest thing to visualize. Okay. So what they do is they want to find the product of negative 2 times negative 3.5. We just did 2 times negative 3.5. So they show that again, right? So they're going back 3.5, back 3.5. And then that's negative 7. That shows that two groups of negative 3.5 is negative 7. So negative 2 groups of that must be the opposite of negative 7. So travel that 7 units away from 0 in the other direction, and you end up at positive 7. Okay. And then they're just reassuring that a negative times negative is a positive, and we kind of already figured out that 2 times 3.5 idea. Okay, let's look at this one. So they want 3 times negative 1.25. Okay, well, what I would do when I'm looking at this is I would just know that negative times a negative is going to give me a positive. And so this is really the same as 3 times 1.25. So I'm just going to do this one. So I'm going to start at 0, and I need to move 1.25 3 times. So 1.25 is right in the middle of 1 and 1.5. If I do that again, I'm going to get to 2.5. And if I do that one more time, I've got to move 1 whole unit and then a 0.25. So that's going to be right in between the 3.5 and 4. So that's actually right here at 3.75. So we get 3.75. Obviously, to do this the book's way, they're going to say, well, think about, they're going to say, think about 3 times negative 1.25, which means we're going to go left 1.25 3 times. And then we need the opposite of that. So that's going to take us all the way over here, okay, to get our negative 3 times negative 1.25. But it's a little bit easier if you can deal with the signs first and then deal with the size of the number. Okay, that's a little bit easier. Okay, but we can also multiply more than 2 numbers together. That's an okay thing to do. And they say that we can use a pattern to find the sign of the product, which is a good thing to do. I think it's always better to maybe look at your problem at first and figure out, is this going to be positive or negative, and then deal with the size of the numbers. Okay. It says first find the product of the first 2 factors. Both their factors are negative, so the product's going to be positive. So they just break down, they're going to deal with the first 2 first. Okay, first 2 first. And so they use some tricks with multiplication, which you don't need to do, but it does make life a little bit easier. When I have the same number on the top and the bottom, I could cancel them out. Now let's say, just to say it, let's say that we forgot to do that. I would be multiplying straight across, but I would look at this right away and say negative times a negative, kind of like they do. They say it's a positive. So I'm kind of treating this like it's not really there. Okay? And so I'm saying now all I do is I multiply straight across. 2 times 1. 2 times 1 is 2. 3 times 2 is going to give me 6. I have 2 over 6, and I can reduce it. I can reduce it because I didn't do the cross reduction that they do, canceling out the 2's. But I do reduce it to 1/3. Okay, so now I've got 1/3 times my -3/5. All right, so I do have to do that multiplication now. So I have a positive times a negative. That's going to give me a negative. And let's say, for instance, I forgot to do that cross-reducing. I have a 3 on the bottom and the top, so I could cancel them out. But let's pretend that I forgot to do that. So I know it's a negative. 1 times 3 is going to be 3. 3 times 5 is going to be 15. That does reduce. It does reduce to 1/5. They're both multiples of 3, so the way I think about doing that is I'm going to divide this by 3, and I'm going to divide this by 3. And you'll notice I do always put the negative up in the numerator when I'm writing it. A lot of times when you're typing it, it just kind of forces it to be out in front, but I write it in the numerator as much as I can. So you know that the product of 2 negative numbers is positive, and the product of 3 negative numbers is negative. So they want us to write a rule for finding the sign of the product of n negative numbers. Okay, so write a rule. So it comes down to this. What is the difference really? What do we call the difference between 2 numbers and 3 numbers? Okay. Well, 2 numbers is even. 3 numbers is odd. Okay. So our rule would be based on whether n is even or odd. We might say if n is even. And so when I had 2 negative numbers, it was positive, and that's going to happen every time. If you think about an even number of negatives, so these 2, when I multiply those 2, it's going to give me a positive. When I multiply those 2, it's going to give me a positive. And a positive times a positive is a positive. And that would continue for any even number of negatives. I could pair every other one up together, every 2 right next to each other. I could pair them together, and that's going to give me an even number. So then the product is even. Sorry, not even. Sorry. The product is positive. If n is odd, what do you think is going to happen? So an idea there would be, then I've just got one more negative. So all these other ones match up and they all give me positives, and then I'm left with that one negative that doesn't have a buddy to kind of cancel that negative out. Okay, all these other ones have buddies. See, these 2 are buddies here. These 2 are buddies here. Buddies, buddies, buddies. These 2 buddies here. Okay. So positive times positive times, a bunch of positives together is just going to be a positive. So then I'm going to have this positive from all these times 1 negative. And that right there is going to make it negative. Okay, but that's a really good problem. Let's find the product of these. So we have, we should look to kind of cross-reduce if we can. I'm going to urge you to think about, if you don't, what's going to happen, right? If you don't cross-reduce, what's going to happen? But I'm going to pair them up by 2's. So I'm going to do the first 2 together. So I'm kind of thinking about these 2. Okay, when I do that, I see that I have a 4 on the top and the bottom. I can cancel those. And more importantly, I have a negative and a negative. So that's going to give me a positive. And when those cancel out, they cancel out to give me 1's So I have a 1 there and a 1 there. 3 times 1 is 3. 1 times 7 is 7. Okay, and now I have that other part of my problem, the negative 2/3. So then I can cancel out the 3's. 1 there, 1 there. 1 times negative 2 is negative 2. 7 times 1 is 7. So my answer is negative 2/7. Okay, next one, group the first two. Cross reduce where you can. 1 and 1. I can cross reduce a 2 and a 4 because how many 2's are there? There's 1 2 there. 4 is really just 2 2's. Okay, so I can cross reduce that, and that makes it really easy. But negative times negative is a positive, so I'm going to get a positive number here. 1 times 1 is 1. 1 times 2 is 2. And then times a positive 4/5. Let me stick with my normal here. So I get 4/5 is what I'm multiplying by. And I can do another cross reduce. Turn the 4 into a 2 while I turn the 2 into a 1. Two times 1, or 1 times 2 is 2. 1 times 5 is 5. Cool. All right, let's look at the last one. Group the first two. I can reduce a 3 and a 9. There's 1 3 for 3 3's in the 9. I can also do the 2 and the 10. There's 1 2, and the 10 is a 5 and a 2. So the 2's cancel, and I get 3/5 there. This is a positive times a negative, so this part's going to be negative. 1 times 3 is 3. 1 times 5 is 5. And rewrite my 5/6. And it looks like more reducing is going to happen. The 5's cancel out and become 1's. 3 is 1 times 3, while 6 is 2 times 3. So 1 times 1, first, positive times a negative is a negative. 1 times 1 is 1. 1 times 2 is 2. So I get a negative 1/2. Okay. So that'll be it for today. We should end with a code word for the day. It only seems fitting that our code word today will be product. Nope, don't do that. So this right here is going to be our code word. Stop getting the code word wrong when I say the code word is product. We're dealing with products today, so it only seems fitting. Have a good day. We'll see you in class.